So yesterday, remember, we started talking about vertical and horizontal asymptotes for our rational functions. So remember, rational functions are just where we are dividing two polynomials. But because we have fractions, we said that there are values that are going to make it undefined, which makes us have like breaks in our graph, which are called the asymptotes. So then we did some practice by looking at kind of where maybe we get some of those asymptotes, as well as how we find some asymptotes. So remember, for our vertical asymptotes, we set g of x, which is the denominator, equal to 0. For our horizontal, we're basically looking at what our values are getting closer and closer to, and that's where we had that case 1, case 2, case 3, where we look at the degree of the top and the degree of the bottom. And then we did some examples with just some finding vertical and horizontal. And the whole reason we worked on that is because today we're going to apply that to help us to graph some vertical and horizontal asymptotes for our rationals. So graphing rationals is not necessarily hard. You just have to remember all of the steps, okay? Which is one, why you have a handout. That way you can refer back to it to look at your steps. And two, why I think it's nice to have acronyms. I think acronyms help me. So you have F, I, A, T, which is fiat, like the car, which is why you have the little car on your paper. But sorry, that's the best I could do, but hopefully it helps at least a little bit. So our first step is to factor and reduce the function. Our second step is going to be to find the intercepts. So to find our x-intercept, we're going to set the f of x. Okay, so remember that f of x is whatever's on top this time. I'll put that up there. So remember that we're talking about the function y equals f of x divided by g of x. So f of x is whatever's on top. Then next up we find our asymptotes using the things we talked about yesterday. Then we didn't talk much about yesterday besides me just saying they're there. We have to check for holes in the graph, which is what that little box over on the right hand side says. Is basically whenever we have a factor that reduces out of the top and the bottom, it's going to become a hole instead of an asymptote. And we'll look at kind of what that means on our graph here in a second. And then lastly, we're going to choose values in each interval. And our vertical asymptotes are going to help us break apart those intervals. Okay, now if you flip it onto the back side, we have a couple of examples for us to work. Now, do you have to follow the order that I'm going to put stuff on there every single time? No. Is it helpful to do it in the same order every time? Yes, because then it's harder to forget stuff, right? Like if you do it in the same order, then you kind of just get used to it, and then you make sure that you always do all the things that you need to do. So, what is our first step? The F stand for? Yeah, factor and reduce. Alright, so here's our F of x. Okay, you actually have a spot that says factor form. So can I factor that? Yes. Yeah. What part of it is factorable? The g of x. What's on our denominator? Are we okay with that? So our x squared plus 2x minus 3. So what does x squared plus 2x minus anything that reduces. Or anything that's the same on top and bottom. Nope. So then that's just factor form. We can't reduce it, which is fine. So then we move on. Our next letter is our I, and it stood for intercept. So we're going to find our x-intercept. So we set the top, or our f of x. What is our top this time? 2. Can 2 ever equal 0? No. Which means that we do not have any x-intercepts. And we might find out why in just a minute. So then what's next? A is for asymptotes. Okay. And we have 2 kinds. Remember, we have vertical. So how do we find our vertical asymptotes?
You said g of x equals to 0.
Alright, and so we factored our g of x. So we're going to set that factored form equal to 0. Okay, so what do we get? X equals -3 and a positive 1. And then we also have our horizontal asymptotes. So remember, this is the one where we need to look at the degree of the top and the degree of the bottom. So what is the degree of the top?
0.
0, because I don't have any x's. What's the degree of the bottom? 2. So our degree of the top is smaller than the degree of the bottom. So we're looking at case 1. So what is our y equals 0? Where is y equals 0 on our graph? Like what else do we call y equals 0?
The x-axis?
Yeah, it goes through the origin, agreed, and it's along our x-axis, yes? Which is why we don't have any x-intercepts, because we have a horizontal asymptote there, right? So like our graph is going to get closer and closer to the x-axis, but it's never actually going to touch it or go through it, which is why there aren't any x-intercepts. Now, are we all okay with all of the stuff that we have found so far? Do you have any questions on whether we got any of those numbers? Or why we did things the way we did? Okay, because then our last step is to pick some test points. So to do that, I'm going to go ahead and graph some of this stuff, because I think it makes a little bit more sense if we see what it looks like. So we have vertical asymptotes at -3, and a positive 1, and a horizontal asymptote at 0. So notice that looking at my vertical asymptotes, okay, how many like parts or pieces has my coordinate plane been broken into?
6.
So ignoring the horizontal asymptotes, so just looking at the verticals. 3. Are you okay with that? Which means that I should have 3 pieces of our graph. Are you okay with that? And so that's why we're going to pick test points in each of those 3 areas or intervals to kind of give us a better idea of where the graph is. Are we all with me there? Oh, yeah. So our first asymptote is at -3. So we want to pick a test point that is before -3. So what's a number? You can pick any number. We'll pick a number that's going to be easy to plug in, make your lives easier. What's a number before -3? -5. Sounds good. Okay. Then our next asymptote is at 1. So we want to pick a number between -3 and 1 that is going to be easy to plug in. 0. Sounds good. And then a number after 1. 3. Sure. Could I have picked different numbers? Yeah, that's why it's called like test points, because you're just testing a couple of points. Okay? So if your partner or someone else at your table picks different points, that's okay. You will still end up with relatively the same looking graph, even if you pick slightly different values. What do you think of that? Yes, no, maybe? Alright, so we're gonna plug in to our function. I would suggest going ahead and plugging in to the factored form, because it does make it just a little bit easier. So the top is just 2, and then I'm plugging in -5. So -5 plus 3 gives us a -2 times -5 minus 1 gives us -6. So we get 2 divided by positive 12, which is also what? 1, 6.
How'd you find all of that?
Sure. I am plugging into that equation.
Okay.
Plugging back into my original. Because these are the x values, right? But now I want the whole point so I can graph it. So to find the y value, I have to plug back into my function. You can plug it in here, you'll get the same thing, but then we don't have to square stuff and add stuff. So like I said, it's just a little easier to go ahead and plug into the factored form. Does that make sense?
Yeah, and you just like plug the x's into the x's in the equation.
Yep, so the -5 went here, so -5 plus 3, and then the -5 had to go here. If I had x's on top, then it would also have to go there. This time, though, it's just a 2, so we didn't have anywhere to plug it in on top. 0 is pretty easy. We still have a 2 on top. If I plug in 0 here, what are we gonna get? 3 times -1. So we just get a -2/3. Yes? And then lastly, 2 divided by 3 plus 3 gives us 6 times 3 minus 2 gives us, 3 minus 1 gives us 2. So we also get 2 over 12, which is also 1/6. Yes, no, maybe. So I'm gonna plot those points. So -5, positive 1/6. So we're just a little bit up. Probably too high. 0, -2/3. So we're a little bit more halfway down. And then 3, 1/6 again. Okay, now, right now it doesn't look like we have a ton of information. However, I actually don't need much more information. Because I like to say, we can kind of think about a good analogy for asymptotes, or they are like black holes. Does anyone know what a black hole is? What's a black hole? It does eat up everything, right? Which includes what? Time and light. Like everything gets sucked into it or towards it. Yes? Okay, so our asymptotes are going to kind of work the same way. They're going to suck our graph closer and closer and closer. Which means that since this point over on the left-hand side is above my x-axis, okay? As I go to the right, we're going to have to approach this graph, okay? It's going to have to come up, and it's going to go closer and closer and closer, going up. Versus, like in my middle part, notice that it's below my x-axis, so it's going to have to get closer and closer, going down this time to either one of my asymptotes. And then our last point is also above, so it's going to go towards that. And then our horizontal asymptote works the same way. Remember that as we go out towards negative infinity or positive infinity, our graph gets closer and closer to that horizontal line. Which is why we only need a handful of points to help us graph it. So that's why we just kind of pick a couple of key ones, and then we're able to fill the rest in. What questions do we have there? our first step. Two factor and reduce. Okay, so can this function be factored? Yes. What's different about this one than our last one? We can factor both of them this time, the top and the bottom. So what multiplies together to give me 3? That adds together to give me a -4.
These are 3 and -1.
Cool. And then what are we going to use on the bottom?
Difference of squares.
Difference of squares. So what is that going to factor to?
X plus 6 minus 6.
Cool. Do we notice anything about our function? We can reduce a what?
X minus 3.
X minus 3. Now, remember, what did our little box say? Whenever we can reduce a factor, what is that going to become? A whole. So this one will have a hole in it. Now, we'll wait until the end when we actually start graphing it to worry about the hole. For right now, we're just going to take this reduced form and we're going to fill in the rest of our information. So that was factor and reduce. What's our next step?
Intercept.
Intercepts. And we're going to set what equal to 0?
F of x.
F of x, which in this case is?
X minus 1.
Alright. So what do we get that x equals?
1.
1. So this time we actually have an x-intercept. Next up we have our
Asymptotes.
asymptotes. So what am I going to set equal to 0 for my vertical asymptotes?
X plus 3.
Alright. And we get?
-3.
And then for our horizontal asymptotes, what is the degree of the top? We can look at a reduced form.
1.
1.
What's the degree of the bottom?
1.
1. So our degrees are equal. So case number 2. Which means that we want to look at the what?
Coefficients.
Yeah, and in this case, both of our coefficients are what?
1.
1. So 1 divided by 1 gives us. Which is why we were able to have x-intercepts this time, because our horizontal asymptote has been moved up. So then, lastly, we're going to take those as points. Going to go ahead and graph. We have an x-intercept at x-intercept at 1. And then we have a vertical asymptote at -3. So how many intervals do we have this time? Just 2, right? If I only have one asymptote, I'm just splitting it in like 2 parts. So what is the value that we could pick before -3?
-6.
Sure. And after -3?
2.
Okay, again, we're plugging into our reduced form here. We do have x's on top this time, so we do have to plug into both. So on top, I have -6 minus 1. On bottom, we have -6 plus 3. So -6 minus 1 gives us -7, and -6 plus 3 gives us -3. So we end up with a positive seven-thirds. Okay. Then I have 2 minus 1 divided by 2 plus 3. So on top we're going to get a 1, and on bottom a 5. So we get 1/5. So I'm going to plot those points. So I have, oops, sorry, I forgot my horizontal. I was like, I feel like I'm missing something. Let's plot that one at 1 this time. negative 6, 7/3 is gonna be what? Approximately 2 1/3, which is like 2.3 repeating, right? And then 1/5, oh, that 2 is slightly above. It's a little bit high, but it's okay. Yes, maybe? Now, remembering to come back, what did I say we have to worry about at the end? Our whole. Okay, so here at x minus 3, how I find my whole is I'm going to take that x minus 3, and just kind of like we do for our asymptotes, I'm going to set it equal to 0, and we get x equals 3. So that means at 3, we're going to draw a hole, or an open circle. So basically, because we were able to reduce the stuff out, we removed like kind of the asymptote, but it still can't equal that because it was there at the beginning, so we just end up with a hole instead.
Is that like the whole line?
Hmm?
Why is it just like, why is the circle like showing a bit through?
Why is it what?
Like, why is it there on the vertical?
Like, why is it?
Like if it's x equals 3, that's like the whole.
It wasn't on the x-axis.
Yeah.
Oh, okay. So if you wanted to know exactly where it was, I could technically plug in 3 into your reduced form. So 3 minus 1 gives us 2. 3 plus 3 gives us 6. So I get like a 1/3. So I actually drew it kind of high, right? But like if you wanted to find the exact point, but in other words, I'm also thinking, right? Remember that this is gonna have to get closer and closer and closer to here. So I was also just kind of like filling in the pattern. So like I know because of this point right here, and that I have an asymptote, and this is gonna have to get closer and closer.
Yeah.
So I know that this point is gonna be somewhere around there. And because it's a hole, it's only at like one point. I only have one open circle versus our asymptotes, which are like the whole line.
Okay.
Does that make more sense?
Mm-hmm.
Okay. So filling that in. And then likewise, remember if I am below my horizontal, then that means that on the right side of negative 3, it's gonna have to go down. Versus on the left side, because we're above that horizontal, it's gonna have to come up, as well as it's gonna come from above towards our horizontal. Other questions?
So do you just ignore the x-intercept at 1? Or do you just like say if it's at a different spot and you still have the...
I graphed my x-intercept on. I have a point there.
But like you drew like a line through it, are you just like ignoring it there, or are you like adding on to it? Cause like we have the little test point right next to it.
I have the what?
The little test point next to it.
Yeah, it's just an additional point that helps us to graph it.
Okay.
Like you would just want to make sure that like for your test point, you don't want to pick that. If you already have that value, like depending on what it was, right? Like if my intercept was already at 2, I'm probably not gonna pick 2. I'm gonna pick something else that's not my x-intercepts.
Okay.
Does that kind of make sense?
Mm-hmm.
Okay. Other questions? Alright. That is all we've got for today.